It's important to have handy a chart or a table similar to the one on the screen, which gives you common oxidation numbers. To begin, assign common oxidation numbers to identical atoms on both sides of the equation. Usually oxygen and hydrogen are assigned -2 and +1. Unless there's a peroxide hydride that reacts, generally you could safely assume that oxygen will be -2 on both sides of the equation and hydrogen will be +1 on both sides of the equation. After all, you're looking for two different atoms, and these atoms have one oxidation number on the left side and a different oxidation number on the right side. So then we begin to determine the oxidation numbers of the remaining atoms, and hopefully you only have two different remaining atoms, because after all you're looking for which atom was oxidized and which atom was reduced. We're going to look for the oxidation number of xenon and the xenon on the left. You could set up the algebra as I've shown and determine that the oxidation number of xenon on the left is +6. Therefore, let's find the oxidation number of xenon on the right side of the equation. And xenon is in its elemental form, therefore the oxidation number of xenon on the right is 0. So xenon went from a +6 to a 0 oxidation number. That means it was reduced. That also means that the xenon polyatomic ion is the oxidizing agent. Next, we'll look at the remaining atom, chlorine. So let's determine the oxidation number of chlorine in the chlorine polyatomic ion on the left, ClO3-. Doing some math, we find that the chlorine has an oxidation number of +5 on the left side. Then we'll determine the oxidation number of chlorine in the polyatomic ion on the right side. Turns out to be 7. So chlorine went from an oxidation number of +5 up to +7. That means chlorine was oxidized. Therefore, ClO3- is called the reducing agent. Here's another example. Again, we'll assume hydrogen is +1 and oxygen is -2. That leaves us with the manganese atom and the carbon atom to analyze. On the left, we only have a manganese ion, and it's in +2, so the oxidation state is +2, and looking at the manganese on the right side, it's neutral, so the oxidation state of manganese on the right is 0. So manganese went from +2 down to 0, so that means manganese was reduced. Therefore it is the oxidizing agent. The manganese ion is the oxidizing agent. Now let's take a look at carbon. Carbon in the compound on the left has an oxidation state of +3. And carbon in the compound on the right has an oxidation state of +4. So carbon went from +3 up to +4, which means it was oxidized. Therefore, the carbon compound on the left is the reducing agent.